Alright guys, so this is your video lesson for today. Don't forget, when you're done watching this lesson, you're going to go do section 5-3 in Big Ideas. It's already open and waiting for you, so make sure that you go in there and give that a shot. So this is called Systems of Linear Equations using the Addition Elimination method. We've already done a graphing method, we've done substitution. I'm going to focus entirely on how to solve problems. I'm not going to focus on any of the word problems because the word problems are identical to what we've done already for graphing, for substitution method. It's just a method of how you're going to solve it. So you'll see some word problems in your problem set tonight, but now you have choices. Hey, do I want to graph it? Do I want to use substitution? Or do I want to use what's called addition elimination? So let's focus on this. You got two equations here. They're both linear. 5 minus y equals 12. And 3x equals the opposite of y minus 4. Now the key to the addition elimination method is first off putting them in the right form. So we want to put both these equations in standard form. The top equation is, so I'm going to rewrite this as 5x minus y equals 12. The second equation I'm going to put in standard form by adding y to both sides. So I would end up with 3x plus y equals -4. Now, what you want to have occur with the two equations is you want to get them to a place where you can add them together to create a third equation. In that third equation, what you're hoping for is that you can eliminate one of your variables. So this one happens to be very friendly. They're not all friendly. We're going to see how we're going to manipulate them to make them work for us. But if I add 5x to 3x, I of course get 8x. But the beautiful part is, if I add the opposite of y to y, I get 0y. So my variable of y has been the word eliminated, hence the term addition elimination. When I add 12 to -4, I end up with 8. Now I've isolated this to one variable. Divide both sides by 8. X is equal to 1. I can go back and substitute in any one of these equations. I got 1, 2, 3, 4 equations to substitute into. They're all equivalent, or should I say they all have the one equivalent solution to them. So substitute wherever you want. But in any event, 3 times 1 is 3. Plus y equals -4, subtract 3 from both sides, and y would equal -7. So there's my solution. I'm going to test my solution, my 1, -7, and of course I'm going to test it in the two equations that were given to me, not the two that I manipulated and put in standard form, because I may have made a mistake. So I'm going to test it. Is 5 times 1 minus -7 equal to 12? Well, yeah, 5 plus 7 does equal 12, so I'm going to say check, that worked. Does 3 times 1 equal the opposite of -7 minus 4? Yeah, 3 does equal +7 minus 4, check. It works in both equations. So that's the gist of how to do this. So we're looking at a second example where I have two linear equations. -3x plus 5y equals 45, and my other linear equation says -3x minus 13y equals -9. Now, both these equations are already in standard form. There's a little twist here. Unlike the last equation that I had, if I added these two equations together, I'm going to end up with -6x minus 8y equals 9 out of 45 is what? 36 off the top of my head. My worst skill. In any event, that doesn't help me at that point. Hey, I added the two equations together. I put them in standard form. I added all my like terms. Right, but nothing dropped out. Now, I will tell you something interesting. I want you to see this. If I were to put this equation in Desmos, this equation in Desmos, and this equation in Desmos, and I graphed all three of them, and I don't know particularly what the 3 lines would look like, but there'd be an X, there'd be a Y. I can tell you this, there would be 3 lines that I would graph such that they would share one common point. That I do know, okay? And as I keep adding these equations to one another, if I added -6x minus 8y equals 36 to this equation, -3x minus 13y equals -9, I'd have a fourth equation that again would have the same solution. if there were a common solution between them. So knowing that, I've got to get the combination so that if I add these together, I get the one that drops out one of my variables. So what I got to do is just a little manipulation here. It's not a big deal. I can't just add these together. We can see that I'm not getting anything to drop, but my eye immediately focuses on the negative 3x and the negative 3x. And I say to myself, both of these are equations. I can do whatever I want. I can add to both sides, subtract, whatever I need to do. So to make my life real easy, what I'm going to do is take one of my two equations, I'll take my lower one, multiply every single term by negative 1. If I do that, this now becomes a plus as opposed to a minus. This becomes positive 9. Now I can add the two equations together. I have an equivalent equation here that is the 3x plus 13y equals 9. And if I add them together, I can see that negative 3x and 3x will eliminate. So I end up with 18y equals, I think it was, when I subtracted, it was 36. 9 plus 45 is 54. Divide both sides by 3, or 18, and y would equal 3. 18 times 3 is 54. So now I'm going to go plug it in and check. Before I do that, or should I say I'm going to get my other variable. I'm going to solve for x. Before I do that though, I want to put this back in its original form. So when I test it, I can test it as it was originally. I want to make sure that always when I test it my original, not something I manipulated. So anyway, I'm going to take the y equals 3. I'll put it into this equation up here. That's negative 3 plus negative 3x plus 15 equals 45. Subtract 15 off both sides. Negative 3x equals 30. Divide both sides by negative 3, and x is equal to negative 10. So now I've got a solution, potentially, that I'm going to check at 10, comma, negative 10, comma 3. So I'll go ahead and plug those in, make sure they work. Grab my eraser over here and erase this. I got a little bit of room to work. And here we go. What is negative 3 times negative 10? It's equal to 30. Plus, what is 5 times 3? 15. Does 30 plus 15 equal 45? Check in the first equation. Okay, let's put in the second equation and see what happens. What's negative 3 times negative 10? That's, again, positive 30. What is minus 13 times 3 would be minus 39. Does that equal negative 9? Is 30 minus 39 equal to negative 9? Absolutely. So I like my solution. My solution at negative 10, 3 satisfies both equations. So now, the next example, let's kind of bring this up a little bit and see if we can get you guys rolling with something that's a little bit more complex, but it's the same concept over and over. I think this should be pretty easy. And they're not quite in standard form yet, or at least the second one's not in standard form. So I'm going to start manipulating and seeing what I'm looking at. And this is kind of what you need to do. You just need to get a lot of scratch paper, be willing to write a lot of equations, maybe use different colored pens, and go through a process. So I'm going to rewrite my top equation that says 2c minus 7d equals 41. That one is in standard form. The second equation, I'll move the 5d over to this. That says plus 5d. If I add that to both sides, still equals negative 7 on that side. The 6c is going to stay there. Now, there's an issue here. What's the issue? If I add these together, this isn't going to work for me. So what I'm going to see is I'm going to have to manipulate either one or both equations in order to get something to eliminate. Now, as I look at the top equation, my eye immediately goes to the 2c and the 6, because I can see that 2 will fit in the 6 3 times. So I can easily make this first term negative 6c, which I could do. In fact, I think I'll do this, just since I'm modeling this, I'll do this for you two ways. Or I can go to the negative 7d and the 5d, and then I can manipulate both of these. I'd have to manipulate both of them and multiply, for example, the top equation, every single term I'd have to multiply by positive 5, so I could get negative 35d, and then the lower equation I'd multiply every term by negative 7, so I could get 35d. So I'm going to do that first. I'm going to pretend like I didn't see what was going on with the c's here, and I'll just go ahead and manipulate these equations. So top one, as I said, I'm going to multiply every term by 5, so it'd be 10c minus 35d equals 41 times 5 would be 205. Obviously, when you start multiplying these things, you know, numbers start getting bigger, unfortunately. Lower equation, 7 times 6c is 42c. 7 times 5 is plus 35d. We're doing this so we can eliminate our variable of d. Equals 7 times negative 7 is negative 49. So now as I add these together, I end up with 52c equals. What's 205? Well, 200 minus 50 would be 150. Be 155, but I didn't take all that, so what is that? 156, if I'm not mistaken. It's just the way my brain works, I'm sorry. C times 52 times one number equals 156. I believe C would equal 3. So if C equals 3, go plug it into one of the other variables to figure out what D is going to equal. I'm just going to write C equals 3 for right now. C equals 3. I'm going to go to a different method here. So instead of focusing on this, what I really should have done was just taken this 2c minus 7d equals negative 41. Should have multiplied this term by negative 3, which would have made this negative 6c. Should have multiplied this by negative 3, which would have made this, what, plus 21d. Should have multiplied this one by negative 3, which would have made this negative 123. So am I right? Negative 123 right there. Minus 123. Had I done that, then I would have used these two equations to solve, and I would have ended up with, what is this? 26d equals negative 130. So what's that going to be? I'm assuming 5. 26 times 5. These are pretty friendly solutions here. So 26 is going to fit into that negative 5 times. So those are your two solutions. Had I done it this way, obviously, then I would be plugging that 5 into one of these equations. Then I would have got the C isolated. I would have got the C equals 3. So let me write the solution out. So you got 3 comma negative 5. You're not going to be doing a combination of what I did to find the C and the D. You're just probably going to do it one way or the other, but although this would work too. And then I'm going to test. I'm going to plug it in and make darn sure it works into what? Into the two equations that I did not manipulate. Remember, you're the one making all these equivalent changes. So if you do something and you make them so they're not equivalent, you're going to get a solution, and that solution is not going to work in the originals. So make sure you plug in the original. What's 3 times 2? 6. What's negative 7 times negative 5 plus 35? What's 6 plus 35? All day long. What's 6 times 3? 18. Is 18 equal to negative 5 times negative 5 be 25 minus 7? Is 18 equal to 25 minus 7? Absolutely. Okay, so I'm going to give one more example loaded with a few fractions. You guys go ahead and give it the best for last. Why don't you take, I'll just pause here. Take about a minute or two, see if you can figure it out. You can pause this and then come back and check the answer. So, how did you do? What's our objective? Our objective is to put both equations in standard form. Okay, well, top equation, put it in standard form, no problem. I see 1, 2, 3 terms. What do I notice? I notice a 4, a 1, and a 2 for denominators. What's the LCM? It'll be 4. If I take that top equation, multiply every term by 4, what do I get? I get 5c plus 4d equals 4 times 11 is 44, divided by 2 is 22. Or should I say 2 goes in the 4, 2 times 11 is 22. Make life easy. Second equation, I'd multiply every term by 3, and I would get 3c plus 3c plus d, sorry about that. That's the whole reason we're multiplying it by 3, so we can get rid of that denominator. 3c plus d equals 9. Okay, now where am I? Okay, well now I'm staring at two equations that are in standard form. Lovely. Now what do you need to do? Well, now I need to make a determination of which variable I want to manipulate, which two variables should I say, maybe one, maybe two, in order to add these together such that I can get, eliminate one of my variables. Tough for me to say, but I think you get the idea. So if I look at this, I know the LCM between 5 and 3 is 15. Okay, great. But if I look at this, my eyes just kind of, it's screaming at me. Hey, all I gotta do is manipulate this. Multiply this by what? -4. So if I multiply this by -4, call this term -4d. Call this term, instead of 9, call it -36. Call this term, instead of 3, call it -12c. Now, I can add these two equations together, use my addition elimination method. I end up with -7c equals, I don't know, what the heck's 22 out of 36? What is it, 14? So it's -14. Like I said, the toughest thing in math for me, adding and subtracting, is brutal. Thank God for calculators. -7c goes, -7 goes into -14 2 times. C equals 2. That's how easy it is. So now that I know the c equals 2, I can plug it into any of these equations. I think I'm going to choose, actually the top one, not that bad. If I put c equals 2 into this one. So 2 goes into this 2 times, it's 5 halves. 5 halves off 11 halves is equal to 6 halves, so d would equal 3. Do it right in my head. You plug it into whatever one you want, I could care less. Any event, I got c equals 2, d equals 3. That's my solution. I'm going to plug it in, make darn sure it works again. So, top equation. That again, I put the 2 in here. 10 over 4 is the same as 5 over 2 plus d equals 3. Does that equal 11 over 2? 3 in the world of halves is equal to 6 over 2. Is 5 over 2 plus 6 over 2 equal to 11 over 2? You bet. Check the second equation. Make sure it works. So put in your c equals 2 and d equals 3. 3 over 3 is 1. 2 plus 1 equals 3. We may have done this one the other day. We may have done this exact same equation. And I think we did it using substitution, as I recall. Ironic. I happened to just randomly pick this out of a book. So anyway, that's the method. Get cracking on your work. Take care. We'll see you, I guess, Thursday or Friday.